discuss on how to use Ollama to set up LightRAG in your system, to do graph-based drag on your documents locally, and also to visualize the created graph in Neo4j. So let's get started. If you did see the episode 1 of Ollama series, I suggest you to do so before you proceed. Link will be provided in the description. Okay, a quick glance on the LightRAG architecture. Input data will be extracted using entities and relationships, which will be indexed to GraphDB with vector embedding. User query will also be embedded to fetch top retrieval from the indexed database using dual level retrieval approach. The retrieval will be re-ranked using LLM based API like Gina re-ranker. In today's demo, we'll skip re-ranking for simplicity. Finally, LLM will be invoked to generate the response. For embedding, we'll use BGM3 model, and LLM will be using Mistral in today's demo. In CMD, you pull BGM3 and Mistral. For me, I already have both of these models, so it was first. Let us check the available models. Yeah, so both the BG model and the Mistral models we have are local. Let's spend a moment on the LightRAG research paper. I shall add a link to of this in the description. Traditional RAG or retrieval augmented generation helps language model by pulling in external knowledge, but most systems still rely on token-based chunks, which often leads to fragmented or shallow answers. LightRAG changes this by bringing in graph structures. Instead of just storing text, it builds a knowledge graph of entities and its relationships, making it easier to understand connections between concepts. It also uses a dual level retrieval approach, one that handles very specific question at the entry level, and second that captures broader high level context. Here you can find the architecture of LightRAG. LightRAG can answer complex queries more coherently, connecting details with bigger picture insights. On top of that, it's designed to be fast, cost efficient, and easy to update with new data. Experiments in the paper show that LightRAG outperforms standard RAG methods, even GraphRAG, by giving more accurate, diverse, and useful answers while using fewer resources. Here you can find the comparison. I'll strongly encourage you to go through this literature if interested. Now we'll see how to set LightRAG locally with Ollama. Here you can find the link of the GitHub code. Please clone this repo in your local. Once you clone the repo, create and activate a virtual environment inside your folder, and then this command installs LightRAG in your system, and post that you run this command to create the env file for you. Once the file is created, go to that file and go to the LLM model mentioned here, comment it out, and the next line also, that is the LLM binding host, that too you comment out. Because LLM model you are using Mistral, as well as for the LLM binding host we are using the Ollama local API. You can go inside this example folder and head over to LightRAG Ollama demo file. Here we are initializing the RAG. You can change the LLM to Mistral 7B, and let the embedding model be BGM3 as it's mentioned here. Here the LightRAG will read the content from the file book.txt, extract all the entities, relationships, create graph out of it. In parallel, it will also do the vector embedding of the graph created. In these examples, all the graphs and vectors will be stored in this simple JSON files. I have created a file here, book.txt, with hypothetical insurance policy details. You can have your own text, but if you want to reproduce the similar result as me, I shall add this text in the comment which you could copy. Coming back to the Ollama demo file. Once the content is indexed, we will test it by asking questions. LightRAG support four different models for query. First is naive, which is simple RAG based on retrieved chunks. Then the local type, which will search for answers in the graph locally. The global, it will search graph end to end. And the last is hybrid, which will bring the best from simple RAG and graph based traversal based search. You may have to change these questions here as per the text you provided under the book.txt. Let us run this file to extract and index the input text from book.txt. So the indexing is complete, and we have received the answers from all four different modes, that is the naive one, local, global, and hybrid. For the hybrid mode, the question was asked, what is the waiting period for maternity benefit? You can see the response is rightly mentioned as 3 years. You can also see the reference from where the answer is fetched. KG stands for knowledge graph and the DC stands for document chunk, which is for vector embedding. So you can see the JSON files under the Deacon folder describing all the entities, relationships, and the vector embeddings. Let us generate the Neo4j based visualization of the graph by running this file. Okay, let's open the Neo4j and see all the nodes. I can see a few orphan nodes scattered around. So if you use better LLMs like OpenAI, etc., the quality of the graph also will be better. Nevertheless, it has come out good. You can see all these leaf nodes are attached to the main Platinum Health Shield policy node. Also, for each entity nodes, this description was created by Ollama based Mistral, which will assist for better graph traversal and to get proper response generated against the query. If you don't have Neo4j, you can generate HTML based visualization of the graph created by running this file. Here you can see the similar graph visualized in HTML. So you observe the graph was created dynamically without any cipher command. Even the query response also generated without any manual cipher query. All are done behind the scene by your LLM. And this is the light track for you. Hope the session was helpful to you. With this, we are concluding today's episode. If it was helpful, please like the video. Make sure to subscribe so that you don't miss any upcoming videos. Thank you.